Hello, this is Danica Dvorak, and this is my Engineering 460 final project. So the problem description, I'm not going to read this whole thing to you, but basically we're trying to schedule for a hospital that's open all the time. There's morning, evening, and night shifts for 18 nurses. We have some hard constraints and some soft constraints. The hard constraints are just kind of what you would assume, like if they work 3 consecutive night shifts, have a few days off, don't have on-off patterns, each of the shifts needs to be covered, all of the days need to be covered, each nurse needs to only work a certain amount of days per 21 days in the schedule, don't work more than 6 consecutive days, etc. The soft constraints, though, are more for employee satisfaction. So this is like a nurse can't work 3 or more shifts in a row. Each nurse has at least 1 day off on a weekend in the schedule, and then all nurses have the same amount of total workload in hours. And then my assumption is that all nurses working 1 shift must be unique/different nurses. So our initialization, this is just talking about the different matrices that I'm going to use. Just kind of get familiar now before I go into my Matlab code. The schedule is a 12 by 21. So 12 are all of the nurses that are going to be working in the day. We have 4 in the morning, 4 in the evening, and then we're going to do 4 in the nighttime because when we get to the genetic algorithm, it's just easier to have the same amount of nurses for each shift. And then 21 is for the 21 days. So the schedule is actually made up of the morning, evening, and night matrices stacked on top of each other. So the schedule rows 1 through 4 is the morning, 5 through 8 is evening, and 9 through 12 is night. Nurses is just an 18 by 1 array, and we use it for counting later. And then the nurse morn schedule, nurse eve schedule, nurse night schedule, and binary schedule are 18 by 21s, 18 for the number of nurses, 21 for the number of days. And these are all binary matrices, 0 or 1, and it's just referring to if that nurse is working that shift or working in that day. The binary schedule is just like, are they working that day? And we use that for some counting constraints later. And then the pseudocode that I have is that we're going to randomly generate 10,000 schedules and calculate the cost for each. For a hard constraint, the cost is going to be anywhere between 10 to 15. A soft constraint, though, is only going to have a cost from 1 to 3. So obviously the hard constraints are going to penalize that, that schedule more than a broken soft constraint. And then we find the best, which would be the minimum cost of those 10,000 schedules. And for that best one, we're going to then apply a genetic algorithm where we're going to flip, swap, and slide. And that's not necessarily how you would normally do it in a genetic algorithm. I'll get more into that when we get to the Matlab code. And then for that genetic algorithm and the 3 mutations, we're going to find the best of those 4, take the best, and then go through that genetic algorithm process 10,000 times until we finally get a best. So now let's jump over to Matlab really quick. Okay, so coming up here, this is just our problem description again. And you see here, we just initialize our best, and then we generate some random schedules. So what we're going to do here is the morning, evening, and night we randomly generate those, and then put them, we're going to kind of transpose those into the whole schedule matrix. And the reason we're doing this is randperm will give us a random number from 1 to 18. For all 4 rows in that morning matrix, and it means that we can't repeat a number from 1 to 18. So you can't have 2 7s working that same morning shift. And then we put that all into the big schedule, and then we call our find schedule cost function, and we'll see that at the very bottom. And once we've done that for all 10,000, well, not once we do it for all 10,000. For all 10,000, we're going to compare that cost to the current min cost. And if it's better, then we make the current cost the best schedule, or we make the current schedule the best schedule, and the current cost the min cost. And then we're going to print out the best of those. And then with that best, we're going to start the genetic algorithm. So normally, genetic algorithms are a flip, swap, and slide, and they're for an array. So you just randomly will find a point in the array and you'll flip numbers, or you'll swap numbers, or you'll slide whole chunks of numbers. But if we make this schedule matrix an array, you're going to run into that problem where the same nurse could be slotted for 2 parts of a shift. So instead of doing it the flipping and swapping and sliding number by number, we're going to do it by shifts. So a flip would mean that for one day, we're going to flip the order of the shifts. A swap is going to be a pairwise swap of 2 random shifts in the schedule. And then a slide is going to be all of the days sliding over to a new day. And the reason this matters is because the front and end of the schedule could change if someone's working 6 days in a row or not. That was one of the constraints. Or if someone is working all of the weekends or not, which was another constraint. So we start here and we do the flipping. So we randomly generate a number from 1 to 21, and that's going to choose which day we're flipping the order of the shifts. And then we just make the evening the morning shift, night the evening, and morning the night shift. And then we find the cost for that. Then we do the swap. Now this looks the worst in the code. It looks the most confusing, but it's the easiest to understand. We're just grabbing one shift on a random day, another shift on a different random day, and we're swapping them. It's just a pairwise swap. So we find those random days, we find the random shifts, and then it's like a case-by-case basis almost. It's a big if loop. You can pause at any time if you want to see that code. And then we find the cost for that genetic mutation. And then the last one is the sliding. So we randomly decide how many days we're going to slide over. Negative is to the left, positive is to the right. And we go through that, call the cost function once again. And then we're going to check which one is the best. So of those 4 mutation, whichever one is the best, we're going to keep. And then we're going to do that genetic algorithm process 10,000 times. And it prints out the best of those. So we can see what our best was of the 10,000 random schedules and then compare it to how it was genetically modified. This is the function that's being called out throughout the code. So these are all the matrices that we had talked about. This is just setting all those up. And those all deal with the first 3 hard constraints. So we start with the 4th hard constraint. This is talking about if a nurse works 3 consecutive night shifts, then they get the next 3 days off. So it goes through the nurse night schedule matrix and checks that. Then we check if a nurse works between 12 and 14 days, and we're going to use just the schedule and count if they're working that day. And if then the total count is less than 12, we give a cost, and if it's more than 14, we give a cost. And then for the 6 consecutive days that a nurse is working, we do this binary schedule. So that's just like, yes, a 1 is yes, they're working that day, a 0 is no, they're not. And we go through once again, we count it up, and if they're working more than 6 days in a row, we assign a cost. The last hard constraint is that the nurse's workload is made up of at least 25% evening shifts, so we go through the nurse eve schedule matrix and divide it by their total number of shifts and figure out if it's less than 25%. And then we check the soft constraints, so we want to make sure that each nurse is not working more than 2 shifts in a row. So we go through and check those. And then, and this should say, my bad, soft constraint 2 and soft constraint 3. Don't know what happened there. This one's checking to see if the nurses have at least a weekend day off during the schedule. So what we did here is that the columns 1, 7, 8, 14, 15, and 21 are weekend days. So if 1 is a Sunday, then 7 is a Saturday, and then 8 is a Sunday. And we just count to see how many of those days they're working. And if it equals 6, if they're working all 6 of those weekend days, then the cost gets added too. And then our last one is that the nurses have the same amount of workload. So the morning and the evening shift have 7 hours in them. The night has 10, so we count it up accordingly. And then here I just said that we're going to penalize if a nurse works more than the mean number of hours plus 1 standard deviation, or if they work less than the mean minus 1 standard deviation, you easily could change this to 2 or 3 standard deviations if you wanted. So then I already ran this code. It just takes a while to run. So I just ran it before this. So when I ran it, the original best schedule out of the 10,000 that we randomly generated was this here. So you can see it's the 12 nurses by the 21 days. And the min cost for that was 144. Once we put it through the genetic algorithm, though, it mutated to this best schedule, and the min cost here was 93. So we definitely have a good improvement there. So switching back over to our PowerPoint, the results here are that the randomly generated schedules cost, when you just randomly go through those 10,000, it's anywhere between 120 to 250. That's just what I've noticed as I've been rerunning this a couple times. And then once you find the best of those, it's usually between 120 and 150. So our example here was about 144. And then the best of the mutations cost is anywhere between 80 and 100, which we saw again. So I hope that was useful. I definitely had a lot of fun doing this project. It was our final problem, and we just pseudocoded it and then in class, and I thought that it would be really fun to actually be able to code this, and I got the opportunity to. So I'm really pleased with how the results turned out, and if you have any questions, you can drop them in the comments below. Thanks, guys.